Do you even mind this symbol, which you see more often than you think?
We see it everywhere and get excited over it when we want to buy that latest trend. Or remember the times you stressed out because your phone showed 2% battery remaining. Well, the percent symbol looks like a fraction, doesn't it? That's because percents are fractions in disguise, with 100 as the denominator. A percent shows the amount of a part out of 100 equal parts.
Keep the following 3% concepts in mind.
When you score 95 points in your 100-point exam, 95, your score, is the percentage or the part of the exam you got correctly. 100 is the base, the whole or total being considered. To get the rate, divide the percentage over the base. 95 divided by 100 is 0.95. Multiply the quotient 0.95 by 100%. So, 95% is your rate in the exam, the part you got correctly out of the whole.
Quite high. Keep studying to maintain that rate. Why use percents instead of just the actual numbers? I scored 95 points. Well, it's because not all exams have the same base or total number of points, right?
Let's use pizzas. Two friends offer you pizza. Joy offers you 1 slice of pizza, while May offers you 3 slices.
Of course, we all want more pizza. What will you choose?
The first instinct is to choose May's 3 slices. But wait! Joy has her whole pizza cut into 2 slices, while May has her whole pizza cut into 8 slices. Joy offers you 1 of the 2 slices of her whole pizza. 1 divided by 2 times 100% is equal to 50%. While May offers you 3 out of the 8 slices of her whole pizza. 3 divided by 8 times 100% is 37.5%. Even if Joy has offered you only 1 slice of pizza, she is offering you 50% or half of her pizza. May's 3 slices is only 37.5% of her pizza.
Grab that pizza from Joy and share it with the rest of your friends.
Percents are used in much more complex stuff. And its latest and greatest use?
In the world's war against COVID, world leaders have relied on scientists and mathematicians to make effective decisions and win over the virus at the soonest possible time. The first step is to know who are infected. People need to be tested early with COVID tests that have high sensitivity and high specificity. A test has high sensitivity when it can detect that a person is infected with the virus by giving a positive test result and the person is infected with the virus. The table shows the sensitivity and specificity data of Sofia SARS antigen test in detecting COVID in symptomatic students in 2 university campuses. The number of students with COVID who showed the positive test result, 32, is divided by the number of all students with COVID, whether they got a positive or a negative test result. 32 plus 8. 32 divided by the sum of 32 and 8, or 40, is equal to 0.8. Multiplied by 100% is equal to 80% sensitivity. This means the Sofia SARS antigen test correctly gives a positive result for 80% of the tested people infected with COVID, the true positive rate. 20% is its false negative rate. A test has high specificity when it can detect that a person is not infected with the virus by giving a negative test result and the person is not infected with the virus. The number of students without COVID who showed a negative test result, 185, is divided by the number of all students without COVID, whether they got a positive or a negative test result. 2 plus 185. 185 divided by the sum of 2 and 185 or 187 is equal to 0.9893. Multiplied by 100% is equal to 98.93% specificity. This means the Sofia SARS antigen test correctly gives a negative result for 98.93% of the tested people not infected with COVID, the true negative rate. 1.07% is its false positive rate. The findings support the use of Sofia SARS antigen test as an added armamentarium in the immediate testing and diagnosis of COVID in symptomatic persons in line with the levels set by the World Health Organization. Re its 20% false negative rate, the US CDC has set guidelines for symptomatic persons who get a negative antigen result. After testing, frequency measures are used to characterize the occurrence of COVID in the population.
Here I have some rice grains and a recycled bowl with 2 holes. Now, I'm gonna pour new rice grains onto the bowl, slowly or fast. The amount of rice grains in the bowl changes. Some rice grains go out of the 2 holes too.
The new rice grains pouring for a specific time period is like the incidence. It is the occurrence of new cases of disease in a population over a period of time. The more rice grains being poured or the more new people getting sick at a given time, the higher the incidence will be. Shown are the 2 types of incidence, their formula's denominators, and what they signify. The attack rate is used like the incidence proportion during outbreaks. The rice grains already in the bowl for a certain time period is like the prevalence. It is the proportion of persons in a population who have a particular disease at a specified time, whether at a point or a period of time. The more rice grains inside the bowl, the higher number of sick people, the higher the prevalence will be. The prevalence rate goes down when more rice grains pour out from the hole with more recoveries or more deaths. Prevalence and incidence are the 2 primary measures of morbidity. Take note of their differences. Meanwhile, fatality rates describe the severity of a disease. The IFR and CFR are the measures used to assess the proportion of infected individuals with fatal outcomes. These 3 frequency measures are computed using their specific formulas, with the quotient converted into percent and then interpreted in context. Increases or decreases in these frequency measures provide the government's targets and basis for their plan of action. Leaders choose the best combination of interventions to improve their country's success in curbing COVID. Vaccination with public health measures is believed by experts as the mechanism that will end the pandemic. Understanding how well vaccines work through their efficacy and effectiveness can boost vaccine acceptance. Let's look into the efficacy of Moderna vaccine. First, find the attack rate of both the unvaccinated and vaccinated groups. Divide the number of cases by the total number of people in each group, then multiply by 100%. For the unvaccinated group, 185 people had COVID out of 14,073 people. 185 divided by 14,073 times 100% is equal to about 1.315% attack rate. For the vaccinated group, 11 people had COVID out of 14,134 people. 11 divided by 14,134 times 100% is equal to about 0.078% attack rate. 1.315% unvaccinated attack rate minus 0.078% vaccinated attack rate is equal to 1.237%. Divide 1.237% by the 1.315% unvaccinated attack rate and multiply by 100% to get 94% vaccine efficacy. This means the Moderna vaccine gives a 94% reduction in COVID among vaccinated persons compared to unvaccinated persons. To correct a commonly mistaken notion, this does not directly mean a 94% protection from COVID. Vaccine effectiveness has the same formula, except that data is generated from the use of vaccines in the real world. Data on vaccine efficacy and effectiveness show that most vaccines offer around 80 to 95% reduction in COVID among the vaccinated group compared to the unvaccinated group, and 100% reduction in severe COVID disease, which unfortunately leads to prolonged hospitalization and death.
Are these numbers not enough to convince you to get that shot?
When a large part of the population will be vaccinated, those vaccinated confer indirect protection to those not vaccinated. Just like in an herd of animals, where the older animals protect the younger ones. This is the concept of herd immunity, and to achieve it, enough people need to be vaccinated. But how many is enough? We can find that with the herd immunity threshold. 1 minus the quotient of 1 over the disease's reproduction number all over the vaccine efficacy, then multiply by 100%. The reproduction number of COVID, pronounced or not, or the number of people that one infected person can infect, was found in studies to be around 3. 1 minus 1 over 3 all over 100% vaccine efficacy, or 1, is equal to about 67%. This means about 67% of the population needs to be vaccinated to achieve herd immunity. As the USA nears herd immunity threshold, CDC are laxing guidelines for fully vaccinated people in resuming activities without masks or physical distancing.
Go get that shot on your arm ASAP. Protect yourself and the people around you.
It's amazing how simple math concepts like percents have highly beneficial applications. The vast knowledge generated, when understood correctly and used wisely, can aid in the search for solutions to the world's problems and improve and save lives. Good news is, all pandemics end.
Keep safe, everyone!